Hey everyone, my name is Justin Woodring, and this is Computing Science with Justin Woodring. Today, I wanted to show you how to set up a basic Java environment and build a select sort. So let's get right into it. So we're right here in VS Code, and all I've done so far is just create a blank new folder called select sort. So inside of this, I'm just going to go ahead and type select sort.java. And then in here, we're going to go ahead and just declare a public class of select sort. And in there, we're going to do public void main string args. Cool. Now, in here, this is kind of your standard hello world. We'll just be typing this out ourselves. And what I'm really trying to show you here is like doing this from the ground up. No IDEs or nothing to just like simplify half the process for you. So if we go straight to the terminal at this point, we should be able to type Java C and then select sort Java. And that compiled, and you'll see on the left we now have a class. So if kind of probably out of scope a little bit for the video, but these class files are the intermediate compiled representation that the Java virtual machine basically takes as a program. So now if we, instead of using Java C, we use Java, just go select sort, and you don't want to use .class, you just want to do this. And not that either. There we go. It's just weird PowerShell syntax, getting confused. But, so basically you just point it at Java select sort, and then it's able to, it just searches for the class file. You don't put .class on the end of it here. And then it runs your program. So, from here, we're going to dive into the selection sort. Now, I'm going to break right here, and we're going to look a little bit at how selection sort works, and then we're going to implement. Okay, so selection sort. We're on the Wikipedia page here, and what do we know about the selection sort? If you are completely unfamiliar with the topic, effectively what you're going to do is take an array of randomly unsorted numbers, and then go from, you just pick the lowest number in the list, and then you just search the entire list, pick the lowest number, swap its position into the first place, or basically the lowest index, and then swap the number in the lowest index back into the position that you swap from. So basically take the first index and swap it with the, take the number in the first index and then swap it with the number that is, or the index that is basically the lowest. So what you get on the first iteration is the lowest number at the beginning of your list. The rest of the list is still unsorted. And if we kind of follow down here, we can see that like in a list that looks something like this, 11, 25, 12, 22, 64, we find 11 first. We put that at the beginning of our list. And then the rest of the list that we have remaining to search, we're going to traverse this instead and find that number. And we're going to find that 12 is the lowest number and then move that to the next position. And really the thing is, we don't need two lists to accomplish this. We can do this all in the same list. This is really helpful for understanding, or this kind of format here is helpful for understanding that one side is sorted and one side isn't. But really, you could look at these as the same list together. So at the same, all the time, you've just got, first you start off with 11, 25, 12, 22, 64, and then you have 11, 25, 12, 22, 64, and then you have 11, 12, 25, 22, 64. So the 25 and 12 switched places. And then you have 11, 12, 22, 25, 64. So at this point, the 22 has switched places with the 25. And so forth until the entire list has been completed. So this is if you're interested in the complexity, it's an order of n squared complexity. Or O, technically not order, it's O of n squared time complexity. It's not the best approach, but it's a simpler algorithm that's easier to start with. Probably one of the more naive solutions that someone might try. And so we're going to go ahead and implement this in Java. So now we're going to jump back and do that right now. Okay, so we're back here in Java. And at this point, I'm just going to go ahead and create another function, call it public static list sort or something like that. So yeah, we'll just call it, actually selection sort would be fine. Generally speaking, in Java, we expect this kind of, you could really either do this kind of, I believe this would be considered Pascal casing, which is the first letters lowercase and the rest afterwards are uppercase. But you could also technically, I mean, you could really use any kind of conventions, but the most common one that you'll see in Java would probably be this style. So going on, we're going to take an argument of an array of ints, integer array, and then in here is where we're going to do most of our actual logic. So we're just going to go for, so we're going to loop over the array. So first we should be able to get the, we're going to do for int I equals 0, I equals, for int I equals 0, I equals the length of the list, or array, or I is less than the array list, length, I believe it's so like that, and then I plus plus, yeah, that should work. I might need to use an array list here. We'll have to see in a second. So from there, we're just going to print, for now, we're just going to print all the numbers in the list. So I'm just going to do just about the print line, numbers in the lists. So let's go ahead and print array sub I right there. And then we're going to kind of basically go up here and do the selection sort. Type in a list of numbers. So see, and let's just declare something here. Int array equals, should be, I think this would be the correct syntax. 5, 9, 8, 3, 3, 4, 6. Okay. And then I should be able to pass this into here, run that, and then, oh, got to recompile. So first go to Java C. So I did not like the fact that I made this public static not void. It should be void. And, well, technically, yeah, it should be void because of the way we're doing this. So do this. It did not like the way that I declared this. So I might be declared like this. And I forgot to put a semicolon on the end. And variable method length. Yeah, so I think I need a, I think I will need a, is it a property? That works, okay. So, and then, again, we can't use this, we have to do like that. So, yeah. Remember, dot length is a property of the array. It's not a method. Other than that, basically, we're just looping over the array. So this is how you're going to declare your integer array, and then we're going to just run the selection sort on the array. Right now, all we're doing is printing out the numbers, so the no sorting is actually happening. I'm going to change this to print, and then add a, looks like that. And the reason why is because if I recompile, it did not like that. You don't want, it would be, we use a concatenator here, so like that. That way we can see the numbers here. So what I actually probably should do, I think, maybe is we could just put this code up here first in the main to print out the array the way it was before, and then print it afterwards, after it's been sorted. So let's go ahead and let's do a system.out print line. So what will this do? So recompile first. It does not like that. You want to do that. That works too. And do this. So boom. We're printing out both our numbers here, before sorted and then after sort. So now we actually get to the whole part where we do the sorting. So this point, we're basically just going to traverse over the array and say, okay, we're really going to need 2 for loops, and this is why. So first we're going to say for j equals 0 from j to array length, j plus plus. And so j should not be array length anymore. J should actually be I. Now, why are we doing it like this? Well, because basically, once we've sorted one number, we don't want to search a number that's already been sorted. We want to go to the next number. So really, as I increments, we want to traverse. With the first one, I will be 0, so we traverse the entire thing, find the lowest number, which is 1, move it to the first position, and then we search this part. So I will have incremented to 1 at this point, and then we will traverse the entire thing, find that 3 is the lowest, move 3 over to the second position, and then so at this point, just show you right here, we basically do something like this: 3, 5, and so now we're going to traverse this and keep performing that until the entire list is sorted. But you notice that our search space is getting smaller each time. So what that basically gives us is the kind of this moving cursor that's based on the larger loop is the search space for the swap. So let's go ahead and change this back to what it was before. So, and then in here, we're basically going to say, okay, cool. My minimum, or not far, but int min equals array sub j. Should always start with the, well, you really want to do this outside the loop. So you're just going to do, for each time you go through, we're going to say int min equals array of j, or I, which is what j starts at. And then we're going to say, well, that's the minimum. So if array sub j is lower than the minimum, replace it. Simple. And really, we want to keep our index here, so not the actual number, but the index. So we'll say that min. Actually, we'll just say min, and we'll do it like this. So keep the index. So the index is equal to I right now. And at this point, we're going to say that array sub j is equal to, if it's less than array sub min, then inside of this, we're going to perform a swap where min now equals j. So from there, we continue to basically progress this logic to the outer loop. And in the outer loop, we say, okay, we found our new minimum. So t temp int temp equals I. No, it's array sub. It would be, yeah, you want to do temp equals array sub array sub I, because it hasn't incremented yet. And then array sub I equals min. Well, equals array sub min. I'm going to get that value. And then finally, array sub min equals, yeah, like so. So what this is really doing is this is just literally a swap, basically saying take, the number that was in I, move it to temp, or and then take the minimum number and move it to I, and then take the number that was in I and move it to where the minimum was. So we're going to kind of basically move down the list at this point, and when it's all said and done, we should be able to print out the same list. And go ahead and do it like this. Move this over here. Just like that. And if this runs correctly, we will get a sorted list afterwards. As you can see, that's exactly the case. The first set is unsorted, the second set is sorted. This is not a particularly complicated problem, but I think it's really instrumental in kind of seeing how you would configure and use a Java program from the get-go. I think that really sums up this project. So yeah, that's it. See you next time.